Okay, everyone. Let's do section 3.6, and so section 3.6, and this is going to be graphing the tangent and cotangent versions of our graph. Should be a cotangent. Now, remember, just a quick review on tangent and cotangent. Remember, tangent, one full cycle of tangent typically went from pi over 2 to a negative pi over 2 to pi over 2. But remember, at these two functions, it was undefined. Okay, so we had vertical asymptotes we had a vertical asymptote at negative pi over 2 and pi over 2, if you remember. So we had a general equation that said all the vertical asymptotes were pi over 2 plus some multiple of pi. That's how we found all the vertical asymptotes for our particular functions. Now, with that being said, you've just got to keep that same thing in mind as we get ready to graph our a tangent of bx plus c, because if you remember, what we did is we would always take our bx plus c and set it equal to our interval here. This would always be our interval, remember. This is our interval for one full cycle. Our period would be pi. Negative pi over 2 to pi over 2 is pi units. Okay? So our period would be pi for a basic tangent graph. So in order to figure out the intervals for a tangent bx plus c, we have to set bx plus c equal to negative pi over 2, and then we set bx plus c equal to pi over 2. If you remember, for sine and cosine, we did this for 0 and 2 pi instead of negative pi over 2 and pi over 2, because 0 and 2 pi was one full cycle of sine and cosine. Okay, now, quick reminder, our A right here, our amplitude. Remember, it's not going to really have an effect on our tangent graph, because the amplitude for tangent is not defined. Okay, for tangent and cotangent, it will be not defined. Basically, all it will do is tell us if it's steeper, if the graph is going to be steeper, or if it's going to be flipped. That's basically all A will tell us, steeper or flipped, for these kinds of graphs. But remember, the amplitude in general does not exist, because if you remember, a tangent graph looks something like this. You have negative pi over 2, and you have pi over 2, and we had vertical asymptotes at these two, and so our tangent graph looks something like this, if you remember. So we'll talk more about that, about actually solving these here in a minute, but I want to also show you cotangent. Now remember, the standard of cotangent is standard interval of one full cycle is 0 to pi, and so our period for it is also pi. Now you're going to set it up the same way. The only difference is we're going to have bx plus c equals 0 and bx plus c equals pi for cotangent. So it's going to be much the same way as with tangent. Now remember, we do have vertical asymptotes with cotangent, but remember, they are found at multiples of pi. So 0, pi, 2 pi, negative 2 pi, that sort of thing. They're found at multiples of pi. is where the vertical asymptotes are found. All right, so there's a quick review of tangent, cotangent. I've already produced a graph on a video on this. It was in your section 3.1 videos. So if you want to go back and watch those again, I think it would be very helpful for you to do that. But let's actually look at one where we graph y equals a tangent of bx plus c. So y equals a tangent of bx plus c. So let's actually look at one of these graphs. So we want to sketch the graph of y equals 3 tangent of pi over 2x plus pi over 4, and we want to we want to sketch this for the interval -7 over 2 to 5 over 2. And let's make these parentheses. Now, why are we making these parentheses? Because remember, at the multiples of pi over 2, we have vertical asymptotes. So it's not defined there, so no need for brackets, okay? It's not defined, so no need for brackets. All right, so what's the period and phase shift? Well, first and foremost, let's take our bx plus c. And because this is tangent, we're going to set it equal to pi over 2. And we're going to set it equal to negative pi over 2. Negative pi over 2 and pi over 2. Okay? So, go ahead and subtract pi over 4 from both sides, and you get pi over 2x equals negative pi over 2 minus pi over 4. Now, if you remember, I told you I like to write it like this. I like to write it pi over 2x equals negative pi over 4 minus pi over 2. Now, I like to write it like that because it's always going to keep it in the form of phase shift first, period second. Phase shift first, period second. That's why I write it like that, okay? So, divide by pi over 2. And so you get x to equal negative pi over 4 divided by pi over 2 ends up giving us a negative 1/2. And our negative pi over 2 divided by pi over 2 ends up giving us a negative 1. So this right here is our phase shift. Our phase shift is negative 1/2. So we know the phase shift is negative 1/2. Okay? Solve this other one over here. And so we get pi over 2x equals pi over 4, negative pi over 4 plus pi over 2. Okay, so divide by pi over 2, just like we did over here. And you should get negative 1/2 plus 1. Now, the first thing, and you can see your phase shift. Here's your phase shift again. But what you should notice is, look at these numbers here. They're different. All right. So your first question should be, Mr. Francis, how am I going to find the period if those are different? Well, go ahead and we know the phase shift, so go ahead and solve this. Negative 1/2 minus 1 gives us negative 3 over 2. And negative 1/2 plus 1 gives us a positive 1/2. So, one full cycle of this period, okay? One full cycle goes from 1/2, negative 3 over 2 to 1/2. That's one full cycle of the period. Now, why do I have parentheses there? Because remember, at versions of pi over 2, we have vertical asymptotes. So I know I have a vertical asymptote. I have a vertical asymptote at negative 3 over 2 and 1/2 in any pi versions of those. So you could do, it'd be negative 3 over 2 and then negative 7 over 2, 5 over 2. Those would all be versions of that, okay? Those would all be versions of that. All right, so now how do we find the period? Well, subtract largest number minus smallest number in our cycle. 1/2 minus negative 3 over 2, and that's going to give you a period of 2. Now you could also use the formula negative c over b, negative pi over 4 divided by pi over 2, and that would give you the same thing, okay? That would give you the same thing. Negative c over b. All right, so you could do that way. Now, I prefer the subtraction. I do prefer the subtraction. Excuse me, the phase shift's negative c over b. I'm sorry. You could get this, negative c over b. I don't want to confuse you. You could get the period is the same thing, remember, as for these would be pi over b. Pi over b. Because the period of the original over b. So pi divided by pi over 2 is 2. Okay? You could get it that way as well. I prefer using the interval because it's just easier. It's just easier to do it like that. Okay? So the phase shift is negative 1/2. The period is 2. Remember, period divided by 2 is going, period divided by 4 is going to give us our increment. Period divided by 4 is going to give us our increment. So our increment is 1/2. Our increment is 1/2. So now, how do we sketch the asymptotes? Well, and you can use a period of 2 to draw in the next asymptote. For instance, here's what we have. We know for a fact, as of right now, we know the phase shift is negative 1/2. We know the period is 2. The increment is 1/2, and one full cycle is this. One full cycle is this. Okay? So if you're having to graph this, and they asked us to graph it from in this interval, they asked us to graph this interval. So if we're graphing here, we know here's 1, 2, 3, 1, 2, 3. Okay, 4. All right, so we know that at negative 1/2, negative 1/2, negative 3 over 2, which is right here, that there's a vertical asymptote. Because with tangent, remember, at the end, with tangent, at the beginning and end of our period, at the beginning and end of our cycle, there is going to be an asymptote. Okay? We also know at 1/2, there is going to be an asymptote. So This is negative 3 over 2, 1/2. Well, where would the next asymptote be? Because remember, we need to find all these asymptotes first because it's going to help us draw our graph. Well, where would the next asymptote be? Well, what you would have is this. Take your period and add 2 to 1/2. So that gives me 2.5. So 2.5 would be our next asymptote. And 2.5 is the same thing as 5 over 2. So we found the one end. Now let's go back the other way. So negative 3 over 2. So subtract 2, which is our period. Well, if you subtract 2, that's going to be negative 7 over 2, which is negative 3.5. Okay, negative 3.5 by subtracting 2. So that's how you get the other asymptotes. It's just by adding and subtracting your period there. Okay, now the fun part, the graph. So we know for a fact that we're going from negative 3 over 2 to 1/2. Now our increment is 1/2. Okay, our increment is 1/2. So that would be, if we went up 1/2, we would be at negative 1, negative 1/2, and 0, and then 1/2. Well, we know these are undefined because they're vertical asymptotes. They're undefined because they're vertical asymptotes. Well, so all you got to do is with our original equation, y equals 3 tangent of pi over 2x plus pi over 4. All right, so go ahead and plug in negative 1. So if I plug in negative 1, that's going to be 3 times the tangent of negative pi over 2 when you plug in negative 1 plus pi over 4. Well, what's negative pi over 2 plus pi over 4? We'll get you a common denominator. This is the same thing as negative 2 pi over 4. Negative pi over 2 is the same thing as negative 2 pi over 4. So negative 2 pi over 4 plus pi over 4 is negative pi over 4. So this is 3 times the tangent of negative pi over 4. 3 times the tangent of negative pi over 4. Alright, so negative pi over 4. So go ahead and punch that in your calculator. And negative pi over 4 should be the fourth quadrant pi over 4. So if you remember at pi over 4, the tangent of any pi over 4 is going to be 1. To determine whether it's positive 1 or negative 1 just depends on what quadrant you're in. So if you remember your unit circle, negative pi over 4 is going to be right here. Okay? And so that should be the point 1 over the square root of 2, negative 1 over the square root of 2. So when you take the tangent of that, which is y over x, tangent is y over x, remember, the y coordinate over the x coordinate, you should get negative 1. So 3 times negative 1 is negative 3. Okay? Take negative 1/2 here. Plug it in the same way. And that's going to give you a negative pi over 4 plus a pi over 4, which is 0. So what is the tangent of 0? Well, remember at 0, it's the point 1, 0. And tangent is y over x. So 0 over 1 is going to be 0, and 0 times 3 is 0. Just plug it in. Plug negative 1/2 in, and you should get the tangent of 0 after you do all the addition in there. And tangent of 0 is 0, and then 3 times 0 gives us 0. Alright, take 0, plug it in. Well, pi over 2 times 0 is 0, so this is just the tangent of pi over 4, which is a first quadrant. So that means it's going to be the same coordinates as the one down below. The only difference is that both of them are going to be positive. So the tangent of positive pi over 4, unlike the tangent of negative pi over 4, is going to be 1 instead of negative 1. So 1 times 3 gives us 3. Alright, so here's how we have it. We have negative 1, negative 3. So go down 3, up 3. Alright, so negative 1, negative 3, and this isn't going to be exact because obviously I am human. So negative 1, 3, negative 3. Negative 1/2, 0 would be right here. And then 0, 3. So when you get a chance to draw this, it's going to look something like this. It should come up through here. That's a poor drawing. It should come up like this through here. It's because of my drawing here. So there's a better picture of it on page 203. My picture is kind of off. Page 203 in your book. So notice where the x-intercept is. The x-intercept is at 1/2. So if you add at negative 1/2. So if you add 2 to this, now where are we getting the 2 from? 2 is coming from our period. If you add 2, that's going to be right here. If you add 2 to 0, it still should be up at 3. So it still should be where we have 1/2. It still should be 2, 3. And this point should be moved over 2. So, I mean, it's going to be the same kind of points here all the way through this graph. So, basically, something like this. As I said, their computer-generated graph looks so much better on page 203. If you want to see what this actual graph looks like in a clearer version, and I'm sorry for my bad drawing, it's page 203 in your book. Top right-hand corner has it drawn all the way out for you. Okay, letter B. Just make sure you look at that so you can see a good drawing. Okay, hopefully you get what I did there. If you didn't understand about moving the dots over by a period of 2, moving them over by a period of 2, that's all I did. So to find these dots over in this other intersection, we would subtract a period of 2 from them. Okay, we would subtract a period of 2. But, so these dots would look something like that. And so you would have, finally I draw one correctly. After drawing 2, I finally draw one that looks right. Alright, so there's one that's how all 3 of them should look, okay? But that's how you would move the dots over. Now, if you don't understand that, let's suppose that you don't understand how I move those dots over by a period of 2. Well, all you have to do is extend this on down this way, extend it on up this way on your T-chart, and continue with your increment of 1/2 until you get to 5 over 2. And then subtract your increment of 1/2 until you get to negative 7 over 2. And you'll have all your x coordinates, and then you could plug them back in and get your y coordinates, which should come out the same. You should have a similar pattern for all of these if you notice. So keep that in mind as you're going through this. As I said, I'm sorry for the drawing. The last one actually is how all of them should look. But hopefully you get the idea of it, of the tangent function. And so our next video will be on cotangent. Thank you.